Gante here from A+ College Ready, here to talk to you about the periodic table and, but most importantly, the periodic trends. Several different elements have been known about forever: gold and silver, copper and tin. But into the 1800s, as more elements were being slowly discovered, several people were working on a way to organize all of these elements. Dmitry Mendeleev, a Russian chemist, compiled a table seen on the right in his stab at trying to organize the elements into some predictable structure. You'll notice that the periodic table he produced looks nothing like the modern periodic table to the left. You'll notice a bunch of blank spaces in his periodic table. His periodic table was very important because those blank spaces represented elements that were yet to be discovered. And his table told people what kind of reactivity they had and about what their mass would be. Soon after people saw this periodic table, there was a flurry of activity as people looked to find these elements that had never been discovered before. These are some alternative periodic tables that you may have never seen before. And my favorite, the periodic table of the elephants. When you look at the periodic table, you may think, they carved out that spot on top so that they could write periodic table of the elements. Or maybe they wanted it to look like a castle with a hydrogen tower on one side and a helium tower on the other. But the truth is, the periodic table is set up in such a way that we can predict certain things about the elements. We can look for trends. So we really just want to think about two things. How many layers of electrons does an element have? And how many protons does an element have? And that's going to govern a series of what we call periodic trends. The first is electronegativity. Some elements just pull harder on the electrons in a bond than others. We call these more electronegative elements. If the two elements have a big difference in their electronegativity, the electrons aren't just shared. One atom wins the electrons and becomes a negative ion, and the other one becomes a positive ion. Another periodic trend we see is atomic radius. Basically, how big a given atom is. Again, we want to look at how many layers of electrons does a given element have, and if they have the same number of layers of electrons, how many protons do they have? The one with more protons is going to make for a smaller overall atomic radius because they pull on the cloud of electrons a little bit more. Ionic radius is a third periodic trend. When elements become ions, either cations, positive ions, or anions, negative ions, if we wanted to compare the size of two ions, we would have to look at the number of electron shells, just like before, and the number of protons. The potassium ion has 3 layers of electrons. The chloride ion also has 3 layers of electrons. Since they have the same number of layers of electrons, we would look at the number of protons to see who's pulling on those electrons harder. Ionization energy is one more periodic trend and is the amount of energy it takes to remove an electron from an atom. You may remember when you learned about electron configurations, something called photoelectron spectroscopy. Photoelectron spectroscopy uses X-rays to knock loose all the electrons from an atom. To figure out the trend, again, we think of who has more layers of electrons, who has more protons, and what is the net effect of those protons pulling on those electrons. This is the PES diagram for lithium. You can see that the 1s electrons right here take much more energy to remove them than the 2s electrons here. We can compare the ionization energies of two elements and measure which one requires more energy to remove those electrons. The last periodic trend is electron affinity. If ionization energy is the energy it takes to remove an electron, then electron affinity is the amount of energy released when you add an electron to an atom. We look at who has more layers of electrons and who has more protons. The number of layers of electrons always makes the biggest difference. The farther out you are from the nucleus, the more electron shielding there is, and the less overall attraction the nucleus has for the outermost electron. It turns out the periodic table is arranged in such a way that elements that behave the same are all grouped together. The groups of the periodic tables are the up and down columns. The periods of the periodic table are the left to right horizontal rows. There are many groups of the periodic table, and it's important that you know a couple along the way. The group 1, alkali metals, are called alkali because those metals are very reactive. Will react with air, will react with water, and when they react with water, they make a base. Base means alkaline. The group 2, right next to them, they're slightly less reactive, but they still make a base when they react with water. Group 17, all the way over on the far right, are the halogens. The name literally means salt maker or salt former. And group 18, the noble gases. They're called the noble because just like nobility back in the day, kings and queens, they didn't interact with the common people, the peasants. The noble gases tend not to react with anybody. There are several other groups of the periodic table you will discover in your journey as you seek to understand the layout of the periodic table.